Figure shows the cross-section of a swimming hole. Points A and B are both located at a distance of h is equal to 5.5 meters below the surface of the water. Find the pressure at each of these 2 points. Here A and B both are located at the same height from the surface of the water. So if we find the pressure at A, same holds good for B also. Okay. Now, to find the pressure at either A or B, we have to find out the data is given to us. It is below the surface, 5.5 meters below the surface. And then the atmosphere, here you should know one thing, the atmospheric pressure acts on this point, okay? So here, like this, atmospheric pressure is acting on the water surface. Now we have to find out the pressure beneath the water surface, and we have to add that pressure to the atmospheric pressure. Then we get the answer. Now, how to find the pressure below the below the surface? For that, here I gave the explanation. Pressure is equal to rho GH. How it will be rho GH? We know pressure is equal to force per area. Okay. And then here, what is the force? Here, the force is the force of the weight of the water on this point at the on the either at A or B, wherever it may be. The force acting on A or B is the weight of the water. Okay, whatever the water mass is there at this point, that water weight will be acting at A or B, okay, or both at A and B. Okay, so weight of the we know weight of the fluid is equal to mg, and then we don't have the direct mass of the fluid. That is why we will go roundabout. Density, we know the density of the water. Here it is the water. So the density of water is equal to mass per volume. Therefore, mass is equal to density times volume. So volume is equal to, we know volume is equal to area times height. We know the area. We can easily find out the area of this part. And then height h that is given to us. And then V is equal to, therefore V is equal to AH, and therefore pressure is equal to, we have to substitute the values here. Okay. Rho is the density times volume. Here this is the mass is equal to density times volume. So density times volume times G divided by area gives the pressure. So rho GH is the pressure at either A or B or at both A and B. So that I wrote here, plus the atmospheric pressure. The atmospheric pressure is acting on the top of the water body, no? So we have to add that one, then we get the answer. So P2 is equal to P1 plus H rho G, where P1 is the atmospheric pressure that we know, that is almost 1 atmospheric pressure, or 1.01 times 10 to the power of 5 pascals. So P1 plus this pressure. Adding both, we will get the answer as 1.55 times 10 to the power of 5 pascals. This is the answer for this question. Hope this helps. Thank you. Bye-bye.